Hello, my name is Jeff Endicott, and I will be presenting this module on qualifying precipitation events and other precipitation events included in the 2002 Construction General Permit. The learning objectives of this module are to identify the Construction General Permit's nomenclature relative to precipitation events, to understand the Construction General Permit's definitions relative to precipitation, and to identify sources of precipitation information. The Construction General Permit has four different nomenclatures that it uses for precipitation events. Those include qualifying precipitation event, forecasted precipitation event, any precipitation event, and measurable storm event. Let's take a look at each one of these nomenclatures. The first and probably the most important in the permit is qualifying precipitation event. A qualifying precipitation event is any weather pattern that is forecast to have a 50% or greater probability of precipitation, also known as a POP, and a quantitative precipitation forecast, also known as a QPF, of 0.5 inches or more within a 24-hour period. The event begins with the 24-hour period when 0.5 inches has been forecast, and the event continues on subsequent 24-hour periods when 0.25 inches of precipitation or more is in the forecast. Now, notice that in the definition of the qualifying precipitation event, I've highlighted the word "and." That "and" is going to turn out to be a very important word as we go through the rest of this module, and we'll talk about that here in just a second. The probability of precipitation and the QPF are not defined in the Construction General Permit. However, the National Weather Service does provide definitions of those terms. The POP, or probability of precipitation, is the likelihood of occurrence, expressed as a percent, of a measurable amount of liquid precipitation or the water equivalent of frozen precipitation during a specified period of time at any given point in the forecast area. And in the context of the National Weather Service, measurable means precipitation of 0.01 or 1/100th of an inch or more of rain. The quantitative precipitation forecast, or QPF, is a spatial and temporal precipitation forecast that will predict the potential amount of future precipitation for a specified region or area. The next term I'd like to define is the forecasted precipitation event. A forecasted precipitation event is any weather pattern that is forecasted to have a 50% or greater chance of producing 0.5 inches of precipitation in a 24-hour period in the project area. The forecasted precipitation event ends when there are two sequential 24-hour periods with less than 0.25 inches of precipitation forecast for each period. It's very important to note, a forecasted precipitation event is not the same as a qualifying precipitation event. QSDs and QSPs must understand the difference and when each one of these definitions applies. The next term to define is any precipitation event. Now, any precipitation event, even though it's mentioned in the Construction General Permit, it's not specifically defined in the CGP. Precipitation in the CGP is defined, though, and that includes the definition as follows. The CGP defines precipitation as any weather pattern that results in precipitation, which includes rain, snow, sleet, or hail. The National Weather Service, on the other hand, defines precipitation as the process where water condenses in the atmosphere to form water droplets that fall to the earth as rain, sleet, snow, or hail. And also it defines precipitation as the discharge of water in a liquid or solid state out of the atmosphere, generally onto the land or water surface. The next term used in the Construction General Permit is measurable storm event. Now, again, this term, while mentioned in the Construction General Permit, it's not specifically defined in the CGP. But the National Weather Service does provide a definition, and their definition of measurable storm event is precipitation of 0.01 or 1/100th of an inch or more of rainfall. Now, let's talk a little bit about the methods and resources available to you as a QSD and QSP to determine a qualifying precipitation event. Remember, a qualifying precipitation event as defined in the CGP glossary, has two key components: a probability of precipitation that's greater than or equal to 50%, and a QPF, or quantitative precipitation forecast, of 0.5 inches or more within a 24-hour period. The "and" in this definition is very important. It's important to note that the construction general permit sometimes refers to a qualifying precipitation event as any weather pattern that is forecasted to have a 50% or greater chance of 0.5 inches or more in a 24-hour period. A 50% or greater chance of 0.5 inches is not the same as a probability of precipitation greater than 50% and a QPF of 0.5 inches or more in a 24-hour period. The working assumption going forward here is that the qualifying precipitation event, as defined in the CGP glossary, that is the definition using the word "and," is what the CGP intends to be used for qualifying precipitation event triggered actions. QSDs and QSPs will need to work with the inconsistent language included in the CGP for the foreseeable future. Forecasts under the CGP are required to be determined using the National Weather Service. The construction general permit does not provide for use of alternative forecasting services such as AccuWeather or WeatherBugs. Qualifying precipitation events are easy to determine using the National Weather Service website. And I've outlined the 6 steps of going through and determining a qualifying precipitation event, but I think the best way will be just to give you an example and actually go to the website and take a look. So the first thing you do is you go to your web browser and you type in the weather.gov URL, and it brings up the page that you see here, and you enter the zip code for your project location. Once you've entered your zip code, you hit go, and it will bring you up this page with all kinds of different weather information regarding the zip code that you've typed in. It's very easy to use. The thing I'd like to point out, though, is we're looking at the red box right now, is that the extended forecast provides a synopsis of the weather looking out about 5 days. However, the extended forecast synopsis does not provide sufficient detail to confirm that you have a qualifying precipitation event. So what you want to do is you'll want to scroll down a little bit on the same web page, and you will come to this page here where we have the detailed forecast. The detailed forecast provides a synopsis of the weather looking out about 6 days. The detailed forecast synopsis does not provide sufficient detail to confirm a qualifying precipitation event. So we need to drill down just a little bit further. And the way you do that is you'll go to item 4 here, and that is click on the forecast weather table interface link. This link takes you to the information needed to confirm a qualifying precipitation event. So once you click on that link, it will bring you to this page. And what you want to do is once you're on this page, you'll want to scroll and zoom on the click map until the project location can be identified. Then click on the project location. Once you've done that, a shaded green box will appear to indicate the area covered by the subsequent forecast. Sometimes you got to click around a little bit in your project area to get the green box to show up exactly where you want. A little bit of trial and error, but once you get it down, it's pretty simple. So this slide here shows you the little green box that we're going to look at for this particular forecast example, and this one is up by Arcata, California. Bottom line, once you've gone through these 5 steps, you've made it. From this web page, the QSD and QSP has access to the information needed to confirm a qualifying precipitation event. Now, the good news is you don't have to go through all 5 or 6 of these steps every time. There are shortcuts. First off, you can enter the URL directly for the WX table, and it will take you right to this particular table. And you can also create a permanent link for the project location. So once you've created a permanent link, you can save that to your favorites, and you can come back to this page every time. So the next thing you want to do is you want to click on the little button down below that says printer friendly link to get a detailed forecast for your particular area that's shown in the green box. And this is what you're going to get. From this location, there's an abundance of information that you're going to have available to you to determine whether you have a qualifying precipitation event or not. Let's kind of zoom in a little bit now. The information to confirm a qualifying precipitation event is located inside this table, and particularly in the data inside the red box that I've highlighted. You can see over on the left column, you can see the probability of precipitation, or the POP, and you can also see the quantitative precipitation forecast, which includes precipitation and snow. Let's zero in a little bit more on this box. So for this particular example, what I've done is I've highlighted red boxes and green boxes so I can talk a little bit about what we're doing here. On the left, what I've done is I've highlighted the 6-hour precipitation, and the qualifying precipitation event begins with the 24-hour period when greater than a ½ inch has been forecast. In this example, the 24-hour QPF is 0.68 inches. Next, in the green box, we look and we see that the probability of precipitation reaches 90% in the period when the QPF is greater than 0.5 inches. That forms a qualifying precipitation event. Now, the big question is, when does that qualifying precipitation event end? Well, it ends when you have a 24-hour period with less than a ½ inch of precipitation. In this example, the subsequent forecast 24-hour period only has 0.15 inches, therefore signaling the end of the qualifying precipitation event. Now, here's an example where we do not have a qualifying precipitation event. In this particular example, the maximum 24-hour QPF is 0.31 inches, which is under the 0.5 inch threshold for a qualifying precipitation event. Furthermore, the POP in this 24-hour period only maxes out at 25%, which is well under the trigger threshold of 50% needed for a qualifying precipitation event. So in this example here, we do not have a qualifying precipitation event. Let's talk a little bit more now about the methods and resources to determine a forecasted precipitation event. A forecasted precipitation event is any weather pattern that is forecasted to have a 50% or greater chance of producing a ½ inch of precipitation in a 24-hour period in the project area. Precipitation events end when there are 2 sequential 24-hour periods with less than 0.5 inches of precipitation forecast for each period. The forecasted precipitation event definition requires evaluation of what we call a probabilistic quantified precipitation forecast. The National Weather Service defines the probabilistic quantified precipitation forecast as an estimate of the chance that any given location will receive an amount of rain that equals or exceeds a certain threshold value. It's important to remember a forecasted precipitation event is not the same as a qualifying precipitation event. QSDs and QSPs must understand the differences and when each applies. QSDs and QSPs will need to work with the inconsistent language included in the construction general permit for the foreseeable future. Now, determining a forecasted precipitation event, again, we're going to be required under the CGP to use the National Weather Service tools. And I'm going to give you a few cautions here when using those tools. When it comes to forecasted precipitation events, resolution of the probabilistic quantified precipitation forecast maps makes site-specific use very impractical. It's also important to note that the PQF maps display time in Zulu time and need to be converted to local time for clear understanding. But the process, just like with the qualifying precipitation event, is basically a 6-step process. It's very easy to implement, and I'm going to go through, and rather than read these steps to you, what I'm going to do is go through an example. So the first thing you need to do is you want to go to the National Weather Service's Weather Prediction Center, and I've provided a URL for you. And once you get to that page, what you want to do is under the 24-hour forecast, you want to select the probability of precipitation of at least a specified amount. You want to select that tab. Next, what you want to do is under viewing options, you want to select 0.5 inches of rain. And what that will do is we'll bring up a map that looks like this. So to check your forecast for the impending 24-hour period, what you do is you go up to the top left of the map where it says valid 24-hour period ending, and you select the 24-hour ending time of interest. In this particular case, again, the times are in Zulu time or GMT time, so you need to make conversions to your local area. Now, as we go through this example, notice that right now we're looking at October 31st with the time ending at 6 hours Zulu time. And notice in the upper left-hand corner, there's a rainstorm up there in Washington. And the project site, on the other hand, is down there somewhere between Sacramento and San Francisco. And what you'll notice that the color-coded map shows white for the area of the particular project. Well, white corresponds on the left-hand side to the probability of precipitation. So currently, there's between a 0 and 1% chance of getting a half inch of rain for the project area located there near San Francisco. Now, what we'll do is we'll advance the time a little bit, and now we're looking at 6 hours Zulu on November 1st, so basically a day later. And what you'll notice is that the storm is moving south. It had gone from Washington, it's now in Oregon. And again, what we'll do is we'll see that the time of this forecast for the next 24 hours, the color coding is white between San Francisco and Sacramento, which means that the probability of a half inch of rain is between 0 and 1%. Now let's advance the time another 24 hours. And now we're on November 2nd. And what you'll see is that the storm now is forecast to arrive in the area in the next 24 hours. And what you could do is you can see that between San Francisco and Sacramento, there is a chance of rain. Now, here's where the problem is in using these maps. It's very difficult to determine the probability of precipitation based on these colors for a small project. It's very, very difficult. In this particular case, it looks like the probability of 50% half inch of rain in this particular area in the next 24 hours is somewhere between the brown, the yellow, or the green color. So it's probably between 5 and about 30 or 40%. Very difficult to use and to be very accurate. And so these tools can be a challenge to use on a site-specific basis. Okay, the next term that we're going to look at is any precipitation event and the methods and resources available to you. Any precipitation event is any weather pattern that results in precipitation, and that includes rain, snow, sleet, or hail. Any precipitation event is based on real times or backward-looking observations at the project location, and is not based on a forward-looking forecast for the project location. Any precipitation event, you could use on-site rain gauges, and in fact, the use of on-site rain gauges is implied by the construction general permit, and we think it's a really good idea to have a rain gauge on every construction project. In some cases, you need to have multiple gauges if you have a long project. When you're using on-site rain gauges, we recommend documenting a nearby governmental rain gauge whenever on-site gauges are used, and are required to use nearby governmental rain gauges when you're working with an active treatment system. The nearby governmental rain gauges provide a reality check to on-site rain gauges. An on-site rain gauge that is deployed in a representative location at the project site, combined with routine observations, recording, and maintenance of the on-site rain gauges, increases the apparent validity of the data of the on-site rain gauge. So here's an example of an on-site rain gauge that is mounted at a construction trailer. If you're looking for nearby governmental rain gauges, they're all over the state of California, And probably the best way to find those is using the National Weather Service's Weather and Hazards Data Viewer. With that resource, I provided a URL here for you. You can identify all the different rain gauges in your particular area. Examples of governmental rain gauges include gauges operated by water and sewer agencies, fire agencies, public works agencies, flood control agencies, and in some cases, schools and universities. There's all sorts of different options out there. The next term I'd like to talk a little bit about the methods and resources for are measurable storm events. And remember, a measurable storm event is not defined in the CGP. However, the National Weather Service defines the measurable storm event as 0.1 inches, 0.01 inches or 1/100th of an inch or more of precipitation. An on-site rain gauge can determine whether a measurable amount of precipitation has occurred. And the National Weather Service's spotter program recommends 4-inch rain gauges. And here's an example of one of those 4-inch rain gauges. These 4-inch rain gauges can be read to a 1/100th of an inch, and they're relatively easy, they're durable, they're not mechanical, and they're pretty much fail-safe. They run about $30 a piece, and I highly recommend use of these gauges as opposed to some of the smaller gauges, smaller opening gauges that are available at home stores and that sort of place. So at this point, I'd like to summarize some key points. The National Weather Service's website is a key resource to maintain compliance with the construction general permit. There are 4 key precipitation-related terms used in the construction general permit when setting requirements. Knowing the difference between these terms makes a big difference. A working assumption is that a qualifying precipitation event, as defined in the CGP glossary, is what the CGP intends to be used for qualifying precipitation event triggered actions. And that is, again, as a reminder, a qualifying precipitation event is any weather pattern that is forecast to have a 50% or greater probability of precipitation and a quantified precipitation forecast that is greater than or equal to a 1/2 inch of rain within a 24-hour period. The event begins with the 24-hour period when greater than or equal to a 1/2 inch of rain is forecast, and continues through subsequent 24-hour periods when greater than or equal to 0.25 inches of precipitation is forecast. This concludes the module on qualifying precipitation events and other precipitation events included in the 2022 Construction General Permit. Thank you.
Hello, my name is Gerald Montgomery, and I will be presenting the Visual Monitoring and Sampling Requirements module. The module learning objectives are to understand the requirements for monitoring based on the risk or type level, as well as the site conditions. We want to understand the triggers and thresholds to determine the required monitoring tasks, and understand the criteria to determine qualifying precipitation events. Monitoring requirements for traditional projects are found in Attachment D, and the linear requirements are in Attachment E. All dischargers shall implement the Construction Site Monitoring Program, or CSMP, from the time construction begins until the project site is stabilized. There are exceptions to our monitoring. Dischargers are not required to physically conduct visual inspections or collect samples during dangerous weather conditions, such as lightning storms, flooding, or winds above 40 miles per hour, outside of scheduled operating hours, or when the site is not accessible to personnel. In this new permit for inactive projects, the discharger may reduce the visual inspection frequency and suspend sampling. All missed inspections and sampling must be explained in the annual report. Now, the visual inspection requirements for traditional projects are defined here in this matrix. So visual inspections to identify and record BMPs that need maintenance to operate effectively or that have failed are to be inspected by either the QSD, the QSP, or the trained QSP delegate. Please note that the pre-rain inspections must be performed by the QSP. Visual inspection requirements for linear projects are quite similar. And again, pre-rain inspections must be performed by the QSP. QSPs shall conduct a pre-qualifying precipitation event, or a QPE, inspection within 72 hours prior to any weather pattern that is forecasted to have 50% or greater chance of a half inch or more of rain in a 24-hour period, as forecasted by the National Weather Service. If extended forecast precipitation information is available, the QSP has the flexibility to perform the pre-precipitation event inspection up to 120 hours prior to the rain. The inspection shall include a review of all stormwater drainage areas, to identify any BMPs that are installed incorrectly or need maintenance to perform correctly, and to verify that all stormwater storage and containment areas have available capacity to prevent overflow and flooding. We conduct these visual inspections every 24 hours during a qualifying precipitation event. Qualifying precipitation events are extended for each 24-hour period that the forecast predicts at least a quarter of an inch of precipitation. We're required to conduct post-qualifying precipitation event inspections within 96 hours after each QPE of a half inch or more precipitation that is measured during the duration of the QPE using the on-site rain gauge. Now, this inspection is to identify if BMPs were adequately designed, implemented, and effective, to identify BMPs that require repair or replacement due to damage, or to identify additional BMPs that may need to be implemented and to revise the SWPPP accordingly. We conduct our visual inspections during scheduled site operating hours. For each required inspection, you must complete an inspection checklist that includes the inspection type, the date and time, the weather at the time of the inspection in detail, the site information in detail, a description of any BMPs that were evaluated and any deficiencies noted, especially those that may result in a release of non-visible pollutants, a list of BMPs inspected, including the erosion controls, sediment controls, and housekeeping. If present, any floating or suspended materials, odors, discolorations, visible sheens, or any other sources of pollutants need to be identified. Any corrective actions required, including any amendments to the SWPPP, photographs of the areas of concern of any of the deficiencies, and the inspector's name, title, and certification. Dischargers shall collect samples based on Table 3 of Attachments D and E, which is depicted here. And you can see that on risk level 1, you do not sample for stormwater discharge, but you do on risk levels 2 and 3. And on risk level 3, you may have to sample if you exceed the receiving water triggers. Of course, any risk level that has a non-visible pollutant that is released will be required to perform that sampling. Samples may be collected by the QSD, QSP, or a QSP delegate that is named in the SWPPP. When it comes to risk level 2 and 3 stormwater discharge requirements, we must collect samples during site operating hours and during the discharge from all discharge points. Collect one sample from each discharge location every 24-hour period of the QPE. If you feel that it is not a representative sample, the QSP may take another. Collect samples of stored or contained stormwater when it is released through dewatering, and do that in accordance with attachment J. We sample for pH and turbidity, as well as any other constituents that may be required by the regional board or another permit. Run-on may be sampled if there is reason to believe it will cause an exceedance. Risk level 3 requirements include receiving waters that must be monitored if the receiving water triggers for pH or turbidity are exceeded. Those triggers are if a pH value falls outside the range of 6.0 to 9.0, or if the turbidity value exceeds 500. Please note that we are no longer going to be averaging for this trigger. So if it's a single sample that exceeds it, then that trigger has been triggered. Receiving water monitoring does not apply if the run-on is tainted from a fire or other natural disaster. And we always must get at least one sample upstream and one downstream from a safe and accessible point. The sampling will be for the constituents that triggered the monitoring. Samples shall be collected once every 24 hours during the QPE, and the specific locations, date, time, and constituents analyzed needs to be reported. The regional board may require additional sampling if they deem it necessary. Non-visible pollutant monitoring requirements. If there's a breach or a spill, we have to implement our sampling and analysis requirements for that non-visible pollutants. If there is evidence of the pollutant, and if those substances could cause or contribute to an exceedance of water quality objectives in the receiving water. We conduct sampling and analysis for non-visible pollutants identified in the SWPPP or known to be on site only when the pollutants could be discharged due to lack of BMP implementation, a spill or leak, or a breach, failure or malfunction, and we sample at least one sample within 8 hours from each discharge location down gradient from the triggered event. Collect at least one sample per applicable discharge location every 24-hour period. Sampling is not required if prior to the discharge, the condition is fully remediated and the proper BMPs are in place. This would need to be documented. Samples shall be analyzed by an ELAP lab. When it comes to sampling, collection, and handling instructions, we want to identify the applicable parameters, request the appropriate number of sample containers, labels, and chain of custody forms from the lab, get the samples to the lab within 48 hours of the physical sampling, or sooner if the lab requires a shorter hold time. Only use containers provided by the lab to reduce the chance of contamination and prevent contamination when collecting the samples. Do not overfill the sample containers. Secure each sample container cap. Label each sample with the date, time, and sampler name and sampler location. You should always use a Sharpie for this so that it's water resistant. Carefully pack the sample container into the cooler and maintain the cooler temperature close to 39 degrees Fahrenheit. And always complete the chain of custody form and make sure that you keep a copy of that. Designate and train personnel for the collection, maintenance, and shipment of these samples. Whoever's going to be doing these samples, gathering these samples, should know exactly how they're supposed to be collected based on that test that is going to be run. And it should all be done in accordance with 40 CFR Part 136. Refer to the SWMP Quality Assurance Program Plan for more information on sample handling. Now, for the water quality monitoring requirements for the analytical methods and requirements, they're the same for both LUP and traditional. We sample for typically pH, turbidity, and then various non-visible pollutants. All monitoring instruments shall be calibrated and maintained per the manufacturer's specification. Records are to be kept of the calibration for 3 years. Risk level and type 2 and 3 dischargers perform pH and turbidity analysis. Typically, that's done on site. Any analysis of that requires laboratory shall be performed by an ELAP lab. And dischargers shall assign a value of 0 for all non-visible pollutant analysis for results less than the reporting limit. Now, the requirements are the same for both traditional and LUP projects for the exceedance response requirements. If the pH is not between 6.5 and 8.5, or the turbidity is over 250, that is a numeric action level exceedance, and it must be reported. And that is per sample, not a site average. There's also TMDL related pollutants that may have a numeric action level, and I would refer you to table H2 in attachment H for those requirements. Now, exceedance response requirements, the pH and turbidity are sampled with a field meter to determine if there's an exceedance. If there is an exceedance, then the discharge shall determine the source of the pollutant and immediately implement corrective actions to meet the best available technology economically achievable and to reduce those pollutants from causing further exceedances. Dischargers shall keep all completed inspection checklists and related documentation with the SWPPP, either on site or electronically, which is a change from the current permit. When it comes to reporting requirements for water quality monitoring for risk level 2 and 3, the discharger is responsible to electronically submit through SMARTS all field sample results within 30 days of completion of a qualified precipitation event, or 10 days if there is an exceedance. If there is an NAL exceedance, an NAL exceedance report shall be prepared when requested in writing by the regional board and submitted to SMARTS through SMARTS within 30 days of the notice. The NAL exceedance report shall include the analytic methods, the method reporting units, and the method detection limits for each parameter, the date, place, time of sampling, visual inspections and measurements, including precipitation, and an assessment of the existing BMPs associated with that sample that exceeded the parameters and what corrective actions will be taken, including photographs and a date of implementation for those changes. Risk level 3 dischargers have to electronically submit all receiving water samples through SMARTS within 10 days of their precipitation event. So it's not 30 days when it comes to the receiving water monitoring. Non-visible pollutant monitoring, we must submit the monitoring results through SMARTS within 30 days after we obtain the results, or within 10 days after an exceedance has been identified. Again, the regional water board may request in writing that NAL report. We must keep the NAL exceedance reports for a minimum of 3 years. And all discharges that exceed an applicable TMDL related NEL shall comply with the water quality based corrective action requirements in section 6.q of the order. So in summary, QSPs have more monitoring responsibilities that are specifically prescribed. The 2022 CGP definition of a QPE is different than the 2009 CGP qualifying rain event. Monitoring safety exceptions have a more definitive criteria, and pre-rain inspections by the QSP can be conducted up to 120 hours prior to the forecasted rain if that data is available. Thank you. This concludes the module on visual monitoring requirements.
Hello, my name is Sandy Matthews, and I will be presenting this module on turbidity and pH sampling, numeric action levels, and receiving water monitoring triggers. In this module, I will review some of the significant changes between the 2009 Construction General Permit and the 2022 Construction General Permit related to the pH and turbidity stormwater effluent monitoring and data evaluation. In particular, I will address how and when pH and turbidity samples must be collected, how to determine exceedances of pH and turbidity numeric action levels, which are also referred to as NALs, and how to determine exceedances of the pH and turbidity receiving water monitoring triggers, and when pH and turbidity data needs to be reported or uploaded into the SMART system. As I go through the slides, you'll see small orange text boxes near the top right of the slide to alert you to changed requirements, and also small orange text boxes in the lower right to point you to the reference sections of the 2022 Construction General Permit. Beginning with the 2009 Construction General Permit, pH and turbidity effluent monitoring has been required. These effluent monitoring requirements will continue in the 2022 Construction General Permit. Some aspects of the monitoring have changed, while others have not. First off, what hasn't changed? There have been no changes to the projects that must sample. Risk level 2 and 3 projects and LUP type 2 and 3 projects need to conduct stormwater effluent monitoring. The NAL values are remaining the same. The receiving water monitoring triggers are remaining the same, and the test methods are not changing. The key things that did change include the sampling frequency, how we determine exceedances of the numeric action levels and receiving water monitoring triggers, and the timelines for reporting our data. As I mentioned, there have been no changes to the parameters and methods and the project types or the numeric action levels. The permit continues to focus on using calibrated field meters for the measurement of pH and turbidity, and the NAL values remain the same, 250 NTU for turbidity and a pH range of 6.5 to 8.5. Similarly, there have been no changes to the receiving water monitoring triggers. The triggers remain 500 NTU for turbidity and a pH range of 6.0 to 9.0. Now I'm going to transition to the changed requirements. Under the 2009 Construction General Permit, traditional projects needed to sample each discharge location and collect a minimum of 3 samples per day. If a site, for example, had 1 discharge point, they needed to sample that 1 point 3 times a day. If a site had 10 discharge points, they needed to collect 10 samples, 1 from each of those locations. The sampling frequency under the 2022 Construction General Permit has changed. Traditional projects must collect a minimum of 1 sample per day per discharge location. So using that same example, if a construction site under the 2022 Construction General Permit has 1 discharge location, it needs to collect 1 sample. If it has 10 discharge locations, it needs to collect 10 samples per day, 1 from each location. For linear utility projects, the sampling frequency under the 2009 Construction General Permit was they had to characterize stormwater discharges from active areas of construction and collect a minimum of 3 samples per day. With the 2022 permit, basically what has changed is the removal of that minimum number of samples. Now, a linear utility project needs to sample 1 or more discharge locations representative of the discharge flows and characteristics. One of the more significant changes in the 2022 Construction General Permit is how we evaluate numeric action level and receiving water monitor trigger exceedances. Under the 2009 Construction General Permit, the samples were averaged to develop a daily site average. An NAL exceedance occurred when the daily site average exceeded the numeric action level value. Under the 2022 construction general permit, the averaging of the sample results has been eliminated. Now, each sample is compared to the NAL values and the receiving water monitoring triggers, and an exceedance occurs when any one sample exceeds that value. As I noted, this is one of the most significant changes in the 2022 construction general permit and requires careful attention by QSDs, QSPs, and QSP delegates to ensure that data is appropriately evaluated. Under the 2009 CGP, or Construction General Permit, data reporting varied depending on the type of project and the risk level. Risk level 2 projects had reported their NAL exceedances within 10 days, and risk level 3 projects had to report all their data within 10 days. And all projects, whether LUP or traditional, had to report their data in the annual report. Under the 2022 CGP, reporting has been standardized. All projects required to sample stormwater effluent need to report NAL exceedances within 10 days of the completion of the precipitation event, and all data must be reported within 30 days. Projects collecting receiving water samples must report that data within 10 days of the event. Data is reported by uploading and certifying it in the Stormwater Multiple Report Application and Report Tracking System, or SMARTS. So that wraps up the changes to the turbidity and pH sampling, numeric action level, and receiving water monitoring triggers that I wanted to review with you today. To reiterate the key points, traditional risk level 2 and 3 projects must sample each discharge location each day of the qualifying precipitation event. LUP type 2 and 3 projects must collect samples from each identified representative discharge location each day of the qualifying precipitation event. Exceedances of the NAL or the receiving water monitoring trigger are based on the evaluation of each sample. Averaging is no longer used. And finally, the reporting of results has been standardized for all projects collecting samples. NAL exceedances are reported by uploading and certifying the data in SMARTS within 10 days of the completion of the event. Receiving water data is also reported by uploading and certifying the data in SMARTS within 10 days of completion of the precipitation event. And all data, regardless of whether it's exceeded an action level or not, must be reported by uploading and certifying the data in SMARTS within 30 days of the completion of the precipitation event. Thank you. This concludes the module on turbidity and pH sampling, numeric action level, and receiving water monitoring triggers.